Before we talk about the kernel-level allocators, I want to describe a particular memory allocation challenge that needs to be addressed. Consider a page-based memory manager that needs to manage these 16 physical page frames. Let's say this memory manager takes requests of sizes 2 or 4 page frames, and let's say it's facing the following sequence of memory requests. The first memory allocation is for a request of 2 page frames, and then the rest of the requests are for 4 pages. So let's say the memory allocator allocates these requests in order. And the end result of this will be that this will be the memory allocation, how the physical memory is used to satisfy these requests, and there are 2 free page frames. Let's say next the 2 pages that were initially allocated are freed. So now you likely can already imagine what the problem is. If at this point a next request comes to allocate 4 pages, there are 4 free pages in the system. However, this particular allocator cannot satisfy this request, since these pages are not contiguous. Let's say the requirement with these allocation requests was for these memory pages to be contiguous. So in that case, this allocator cannot meet this requirement. This example illustrates a problem that's called external fragmentation. This occurs where we have multiple interleaved allocate and free operations, and as a result of them, we have basically holes of free memory that's not contiguous. And therefore, requests for largest contiguous memory allocations cannot be satisfied. In the previous example, the allocator had a policy in which the free memory was handed out to consecutive requests in a sort of first-come, first-served manner. Let's consider an alternative in which the allocator probably knows something about the requests that are coming. It knows that they will be coming for consecutive regions of 2 and 4 page frames. In the second case, when the second request for allocating 4 pages comes, the memory allocator isn't allocating it immediately after the first allocation, but instead is leaving some gap. The second allocation for 4 pages comes in at a granularity of 4 pages, and then the rest of the allocations are satisfied further below. Now, when the free request comes in, these 2 first pages are freed. The system again has 4 free pages, however, they're consecutive. Therefore, this next request for 4 pages can actually be satisfied in the system. What we see in this example is that when these pages are freed, there is an opportunity for the allocator to coalesce, to aggregate these adjacent areas of free pages into one larger free area. That way, it was more likely for the allocator to satisfy these future larger requests. This example illustrates some of the issues that an allocation algorithm needs to be concerned with, to avoid or to limit the extent of fragmentation, and to allow for quick coalescing and aggregation of freed areas.